Well, we do have a lot of other things to talk about today. I'm actually going to start out with, while we don't know whether or not Moore's Law is dead, depending on who you ask, Gordon Moore himself, the creator of Moore's Law and Intel co-founder, has died at the age of 94. And, you know, he really did have a huge impact on the whole semiconductor and computer industry. There's a lot of articles about him and his life if you're interested, and I will link this one in the description. Let's jump into FSR3 now. So introducing FSR3. So AMD did talk about FSR3 at GDC, and we do finally have their slide deck. However, I will say it's not as much detail as we maybe hoped. Now, speaking of detail, they went into incredible detail on FSR1 and FSR2 and a whole bunch of FidelityFX tools, how they're improving tons of stuff. But let's just start with what they said about FSR3, because I think that's the thing that most gamers are the most excited about. So, they're mentioning that with FSR2, we're already computing more pixels than we have samples in the current frame, talking about upscaling, lowering the game at a lower render resolution, and outputting an image that has more resolution than your input. We could generate even more by introducing interpolated frames. So they are very clearly saying that FSR3 is interpolating frames, which is also what DLSS 3 does, frame generation. It also interpolates frames. You insert fake frames in between two real frames. They say it can achieve up to a 2 times frame rate boost in the process, again, because you're inserting a generated frame in between, an interpolated frame in between two actually generated frames, so you can double the amount of frames. The good news, they say, is there's a high probability there will be at least one sample for every interpolated pixel, and that there's no feedback loop, which means interpolated frames will only be shown once, so any interpolation artifact would only remain for one frame. This is similar to what we see with DLSS 3 frame generation, where even though there are image artifacts in the generated frames, because they're on screen for a very short amount of time, especially when you're running at a high frame rate. This is where a lot of people say, you know, DLSS 3 is weird, frame generation is weird, where you want to run it at a high frame rate already, and then it boosts your frame rate even higher, because then there's less variance between the two images that you're interpolating, and then also the shorter time each interpolated frame is on the screen, the less you notice the artifacts. And what they mean by there being no feedback loop is then you're not using the artifacts to generate another frame, which would then have even more artifacts based on that generated frame, because the generated interpolated frames are happening, they're using the real frame data, not the previous interpolated data to generate the next one. However, they do mention some challenges. They can't rely on color sampling to correct the color of outdated samples. That non-linear motion interpolation is hard with 2D screen space motion vectors, and interpolating final frames means all post-processing and UI needs to get interpolated. So what's going on here? Well, one thing is the non-linear motion vector problem. So here, the reason why Nvidia says that DLSS 3 frame generation cannot run on anything besides their 4000 series hardware is because their 4000 series comes with more advanced and powerful optical flow accelerators. So there is hardware acceleration for optical flow, and AMD is trying to do this without any of those without any kind of hardware acceleration. They want this to be able to run on any GPU pretty much. So they do this diagram, which I am currently blocking, so you know what? Maybe just Thanos snap myself out of existence. They're showing us here basically native rendering without upscaling. You would just do the main render workload, you would do the post-processing in UI, and then present a frame, and then that begins again to begin working on the next frame. They're showing that what FSR2 does is it reduces the main rendering workload time by reducing the resolution. Then you apply upscaling, which takes time, but takes less time than had you actually just rendered at the full normal workload. Then you render the post-processing and UI, and you present a frame. Then it begins working on the next frame. Again, it's a shorter workload because it's at a lower resolution. You do the upscaling, post-processing, UI, you present a frame, and begin again. So what they're showing now is what that process will look like with FSR3 using, and they're still using the FSR2 while they're using FSR3. And I do want to mention that they have not said anything about being able to use FSR3 without FSR2 as at the same time, whereas DLSS 3 frame generation does allow you to separate those out. Anyway, in other words, you can run frame generation with DLSS 3 on a native image. Anyway, so here it's showing you that you would do this same FSR2 bit to begin, right? You start out the same way. You present the frame, and then notice that they then present another frame right here, right? And then you get another frame right here. So this frame here and this frame over here are the same two frames you would have got here and here using FSR2. Notice it's delayed a little bit, and during that delay, what you would get is this extra frame. This would be the interpolated frame, okay? So that's what they're showing in that graph. They're showing us that we get an interpolated frame in between these two, but notice that it does slightly delay getting you your next real frame, and because of that, that's where you get the slightly increased latency. This will still have the increased latency that we get from DLSS 3 frame generation. Who knows if it's the same amount, but you get some. So they're talking about this, that FSR3 combines resolution upscaling with frame interpolation. So again, they're being very clear that it does combine the resolution scaling with the frame interpolation. And then they say latency reduction, and they're saying that FSR2 to FSR3 will be an easy transition for developers, and it will have a permissive open source license, which I think is the best thing about it, really. Is how open it is, right? Open source, it runs on so much hardware. Now, when they say latency reduction, here's the thing. Nvidia is comboing this with their Nvidia Reflex for some latency reduction. AMD does have AMD anti-lag. To my knowledge, it's not quite exactly the same thing. And I'm wondering if why they're forcing it to work with the resolution scaling and not separately. One of the reasons could be that one of the ways that you reduce latency is running at a higher frame rate as your baseline. So maybe FSR3 has to use some aggressive upscaling on the image just to get to speed up the game to a point where applying FSR3 works. Again, I'm just kind of trying to read into some of the details here. So here's their early look at FSR3 tech. So FSR3 benefits from synergies between upscaling and interpolation. It leverages motion. By the way, I think these synergies are maybe partially, what they're already calculating due to the upscaling process. But I think it's also talking about the latency there, right? You cut down on latency through upscaling, and then they'll apply the interpolation. Leverages motion vectors and AMD fluid motion to produce interpolated frames. So I believe the fluid motion there is the interpolation, but then they'll work motion vectors into that. It has good motion it says good motion estimation is key for interpolation, but that's one of the things that they've said is difficult to do. Additional internal information from FSR2 can be leveraged. So the information they're getting from FSR2 can help them with this process. Latency reduction is a focus area. Gamers need both high frame rate and lowest latency possible. Existing FSR2 integrations will be more easily transitioned to FSR3, so this could mean that what they're basically just flat out saying is if the game already supports FSR2, it shouldn't be too hard to add in FSR3, and they will allow an MIT license to allow optimal flexibility of integration if needed. And then this is the conclusion of their presentation, which notice does not include a release date or anything like that for the technology. Now, this presentation only talked about FSR3 at the end. The rest of it started with FSR1, going from spatial upscaling to FSR2 with temporal, and then all of the problems that they solved with that. Honestly, guys, this is a fascinating slide deck, and I will link it here. This goes into so much detail about FSR2, how they're reducing ghosting with clamping and all sorts of stuff. Honestly, it's more technical detail than I think I need to get into for my video. But I think there are some of you who would be fascinated to look at how they did this. Because one of the interesting things about FSR2 is how it does the kinds of things that DLSS does. Maybe not as well, I do think DLSS looks a little better, but that it has to be hand-programmed by humans rather than a machine learning algorithm just kind of playing with a statistics network to figure out, how to tweak all the little algorithms. Now, again, this was a big thing about FidelityFX in general, not just FSR3. And so they unveiled a FidelityFX SDK with some new FidelityFX effects coming out in Q2. Now, to be clear, this does not necessarily mean that FSR3 will be a part of this coming out in Q2. So as a lot of people mislabel FSR as FidelityFX. FSR is FidelityFX Super Resolution, but within the FidelityFX umbrella is actually a number of other technologies. So what they've acknowledged, though, is with this quote, is that they honestly just go over a whole bunch of problems with this. They're not all programmed in the same way. The documentation is not always great. They have a lot of deficiencies. There's this little checklist here that I think does a good job of summing some of it up. So all FidelityFX technologies previously had the MIT license. They were open source. They had DX12 support, and but then a bunch of them were inconsistent on some of the other features, whether they offered Xbox support or Vulkan support or were easy to integrate, had a clean architecture, consistent user experience. They're going to improve all of this across the board for all of their FidelityFX suite of effects, and then release it all as FidelityFX SDK with all of those boxes checked. Including Xbox support, which is asterisked as coming soon. So this could be easier to implement these technologies into games. Now, with that in mind, though, they did introduce some new FidelityFX technologies. So there's let's see, I think they talked about, I thought this article had it right here. Yeah, here we go. 3 new technology effects, including FidelityFX Depth of Field, FidelityFX Lens, and FidelityFX Blur. Those are all pretty obvious what they do with motion blur, depth of field, and lens effects. So yeah, nothing too crazy there. Although they did get into, where is it here? There was a very interesting presentation, although it's very detail heavy, on a new real-time global illumination technology using Radiance Caching to improve its performance. I thought this was fascinating, but honestly, guys, I think this is a little too in-depth of a paper for me to go into all the details here, but I will link it here. But they did present this, and what it looks like to me is some really excellent real-time lighting, and the main idea is that they're using Radiance Caching to speed up the process, to make it easier to compute. They even did have a video demonstrating some lighting running in real time, using this technology and how the lighting is dynamic, it changes, bounces, all of that. It looks very good. Again, those will all be linked in the video description. Now, let's get into some other tech news for today. We've got the Boundary Early Access launch. Now, this game is kind of from a more independent studio, but it had been known a few years ago for releasing a big DLSS and ray tracing demo. But in the final early access launch, it's not going to have any DLSS or ray tracing features, but it will have FSR2 and XeSS. So that is interesting. We also saw Atomic Heart being a ray tracing early benchmark and poster child game, and then not actually launching with ray tracing enabled, although it did launch with DLSS. Anyway, so that was an interesting to note. Now, Gigabyte claims next-gen Ryzen CPUs arrive on AM5 this year. What? Next-gen Ryzen CPUs on AM5 this year? Shouldn't they be in 2024? That's kind of confusing. I saw this headline at Tom's Hardware. The actual source they're getting it from is a Gigabyte press release on the Gigabyte page. And if you read it, it says the next generation of AMD Ryzen desktop processors that will come out later this year will also be supported on this AM5 platform. So, you know, it's very possible that Gigabyte is just wrong. It's also possible they're talking about some other type of Ryzen processor beyond just like the actual next generation, although they did say the next generation. Maybe they mean like sometimes the ones with like the APUs on them get like a next numbering scheme. I don't know, but I'd be surprised if we saw the actual full next generation on here. Now, in other huge news, LTT and some of its Linus Media Group channels was hacked. And that's kind of a big deal. He has a video. He does have the channel back and has a video out here on the topic. I wanted to mention that I've actually been targeted by the same thing. How it actually happens is so that you get a sponsor request through your channel email, and it all feels very legit. But then they want you to unpack their the details of the agreement. But for some reason, you need to extract the PDF, and the file extension is wrong. And at that point, I bounced out of there. But somebody within Linus Media Group did extract the file, and what it does is it grabs the session token in your browser, so it doesn't actually need your password or anything, and it just clones your web browser session. And then they have, if you're logged into your account with access to your channel, they now can put up their crypto live stream thing and try to trick people. All of that. This is a widespread issue. It is terrible, and it needs problems solved. It's one of these scary things about doing YouTube. Anyway, Nvidia quietly boosts the video encoding capabilities of GeForce GPUs. Basically, there were software limitations limiting how many streams could be produced by the GPU all at once. And this was a software limitation to try to push people into buying the more expensive professional hardware. However, there has been third-party tools for removing these apps for a long time. But those third-party tools are, third-party tools. Not everybody wants to install that kind of thing. But it looks like it was quietly increased to, I think, 5 live streams on NVIDIA GPUs. Now, a lot of people don't need that, but some people do, and this is good news. There are also new NVIDIA drivers out. And in addition to support for Diablo 4 and The Last of Us, there's a really interesting note here in the fixed issues: disable Horizon Zero Dawn resizable bar profile on Intel platforms. This relates to in my last video and reporting on Hardware Unboxed findings that the resizable bar in Horizon Zero Dawn on Intel's platforms, but not AMD platforms, was causing, AMD platforms saw some degraded performance in CPU limited situations, but the Intel 13900K platform saw significantly worse. So it looks like NVIDIA is aware of that issue and has fixed it by just disabling the resizable bar profile. Remember, NVIDIA uses a whitelist, so even if you turn on resizable bar on your PC, only certain games will use it. Unless you use NVIDIA Profile Inspector, which is a third-party app, speaking of those, third-party apps giving you more control over your NVIDIA GPU than NVIDIA does, you can enable resizable bar profiles manually. And I've explained how to do that in another video. But anyway, speaking of graphics drivers, Intel has a new graphics driver out. And while it's not just optimizations for Resident Evil 4, though, they've got some interesting slides, although they do tout their Resident Evil 4 performance as their A750 being a little bit better than the RTX 3060 at both 1080p and 1440p. And they mentioned that then if you look at it as performance per dollar, because the A750 costs $249 and the 3060 costs $390, although you can actually get them less than that, but whatever. Anyway, it's still a big price to performance advantage. The main issue here is notice that Intel doesn't put AMD in the graph, because AMD also has a significant price to performance advantage over NVIDIA here, and then the Intel lead would look a little less impressive there. But another big deal, I don't know how big of a deal it is, but I think it's good, is that their driver download size was huge. It was 1.3 gigabytes, and now it's down to 604. They have apparently found a much better way to compress it, so without wasting space on people's PC and people's time downloading it. So that's good news. So further improvements to Intel graphics drivers. Acer Arc A770 Predator BiFrost GPU, which is 16 gigabytes of VRAM, drops to $339. So, again, just more Intel news on the price to performance. The prices are continuing to come down. So again, if you're, I still don't usually recommend them over AMD because those both offer very good price to performance, and Intel still in my testing had some more headaches to deal with. However, for people okay with dealing with some more headaches, the price to performance on the Intel GPUs is certainly getting very interesting. And especially if you need 16 gigabytes of VRAM at this price point, I think they're really the only option. And then also, this is the cheapest way to get into like, I mean, not this GPU being, but the Intel GPUs are the cheapest way to get in like AV1 encoding, things like that. So there's a lot to be said there. Now, we've seen Der Bauer, I'm seeing this in a videocards.com article reporting on it, but Der Bauer has overclocked an RX 7900 XTX to 3.2 gigahertz at 650 watts with the stock cooling. Now, the stock cooling on this one is the water-cooled Power Color Liquid Devil, so it's very good stock cooling, but still, we're not talking liquid nitrogen or anything like that. Now, watch the full video for all of the full details, but the overall performance in 3D Mark here, gain is insane over the base model. Compared to the made by AMD base model, and then with the Liquid Devil pushed to 650 watts and 3.2 gigahertz, it's a 28% improvement in the 3D Mark score. Now, that doesn't mean everyone's going to be able or want to run their card like this in gaming, and it's also of note that it still didn't quite catch up to a stock RTX 4090 Founders Edition. But that is a massive gain over the base model, so very impressive. But again, they had to go to 650 watts to do that. So when AMD in a recent video I did a quote from them being asked why not compete with the 4090. They said they could, but they chose not to. And I think this might be indicating why they chose not to. I think they would have had to go to some ridiculous 650 watt power target, and it turned out that the 4090, while you can increase it to that kind of power target, it doesn't need it to deliver the performance that it delivers. It still draws a ton of power, but not 650 watts. Hey, with CSGO 2 coming out on the Source 2 engine, I was interested if anybody had benchmarked it. I would benchmark, but you have to have access to the beta, although more on that in a second. Actually, I think there's a build of it that got leaked, but anyway, whatever. I haven't found a lot of like really in-depth testing, but it looks like on more, according to eScoreNews.com, more mid-range PCs like a GTX 1070 are running the game at very good frame rates, very competitive. So nothing to be too worried about with the like minimum system requirements. However, they did mention that like on an integrated laptop that could run the old game fairly well. So like a Ryzen 5 3500U. With an integrated GPU and only 8 gigabytes of RAM, that they were dropping below 10 FPS in gunfights and things like that. Tried upscaling, it didn't completely solve the problem. So it looks like on really weak low-end integrated hardware, that kind of thing, it still might not run smoothly. But on pretty modest mid-range hardware, you can still get pretty high competitive frame rates. Now we see ASUS A620M motherboard BIOS spotted, no support for PCIe Gen5. Now we still haven't seen any A620M motherboards actually come out. So in other words, AM5 motherboards are still fairly expensive, but they're also fairly high quality. The A620M, this apparently, the BIOS date comes from in October, I believe, of last year. So it's unclear if this is actually something that'll be coming out. But it is interesting to note that it didn't support any PCIe Gen5, but maybe at some point we will see cheaper AM5 motherboards that just don't have PCIe Gen5 support. We'll see if that ends up coming to pass. Now, speaking of things that may come to pass, it looks like AMD's hybrid Phoenix APUs will feature performance and efficiency cores. These aren't the Phoenix APUs that I think we've been advertised, although it's looking like in AMD's processor programming reference guide, For the AMD Family 19H Model 70H CPUs, it does list a performance core and an efficiency core listing here. So basically showing that AMD might be going a similar route with even a similar naming scheme on at least some of their hardware in the future. And we'd seen a recent leak on one of my last videos pointing to this same configuration. Now, Intel Alder Lake H CPUs up to Core i7-12700H are now available with desktop motherboards. So Alder Lake H CPUs are mobile CPUs, but it's looking like a Chinese company, Erying, I don't know, I'm probably not pronouncing that right, is offering them soldered into a motherboard, which could then be used in a desktop form factor. Apparently, this is something that they did with previous 11th gen CPUs and were somewhat popular. And so, hey, if this is something that would be interesting to you for some kind of a build, it's a thing. Now, I meant to talk about the Counter-Strike 2 beta leaking after I talked about the Counter-Strike 2 beta, performance, but apparently there is an offline version where the files did get leaked out. Anyway, sorry, that was a bit out of order. Now, the Diablo 4 open beta has kicked off, and Blizzard is warning of lengthy queue times, and also they're not warning of, but remember, this is the game that was frying some 3080 Ti's, so I guess careful on that one, although I think the vast majority of people will be fine. But again, 3080 Ti's were also getting fried by New World, so I think there were just some models that just couldn't handle games running at too high of an uncapped frame rate or something. Anyway, in other game news, Elden Ring's ray tracing mode has finally launched. Now, in performance-wise, I did find DSO Gaming taking a look at it. Now, Elden Ring still has a 60 FPS frame rate cap, so the highest it will go is 60 FPS. They looked at 3 GPUs, the 2080 Ti, the 3080, and the 4090, and they looked at them at 1080p, 1440p, and 4K. And with ray tracing on, only the 4090 was able to always run even 1080p at a flat 60 FPS, although the other ones were pretty close. And then at 1440p, again, only the 4090 was able to hold 60 FPS, and at 4K, the 4090 was still able to hold 60 FPS. But the 2080 Ti dropping down below 30 FPS at times. By the way, this is the minimum and average frame rate, I believe, is what you're seeing here. Minimums and averages. So the average, anyway, you see it. Minimum, average, minimum, average, minimum, average. Now, is it worth it? Note that without ray tracing turned on, all these GPUs have no trouble holding 60 FPS up through 1440p, and the 3080 can still hold 60 FPS average at 4K, whereas the 2080 Ti just dips into the 50s. So this is clearly indicating a massive performance hit going from RT off to maxing out the ray tracing, and Elden Ring still did not implement any kind of DLSS or FSR support, so that's rough, meaning you can't just kick on image scaling to make this doable. But hey, if you got a 4090, I guess you can run some ray tracing here. Now, how about the image quality? It's, again, this is from their testing. So this is RT on, RT off, RT on, RT off. It does get you, so basically RT in this game is shadows and ambient occlusion, and it is better, but that was quite a performance hit for that visual distinction. The actual article has much more image quality testing, which I'm not going to show you because I shouldn't just steal everything that they did. I should point you to their article in my video description, and you can see a lot more image quality comparisons. Nvidia Omniverse is creating lifelike AI-based animations in Stalker 2 and Fort Solis AAA games with ray tracing. So honestly, I just clicked the wrong button. I think one of the biggest graphics improvements I'd like to see in games is better facial animation while characters are talking. This seems to be one of the hardest things for a lot of games to get right, and to me can stand out a lot more than, shadow quality or something like that. But the quote here via Nvidia, but this is a WCCF Tech article reporting on it, is that the latest upcoming Omniverse audio to face generative AI update includes Mandarin support, overall facial animation, and lip sync quality improvement across multiple languages. And it also brings the latest in real-time RTX rendering and the first real-time ray trace subsurface scattering shading for improved realism. So anyway, if you could speed up game development by getting accurate face animation and lighting by just recording the audio and it just syncs up to it automatically, that would be, I think, really good tool for game developers. So that looks awesome if it works well. They did show it off, and it did look like it was working well in their demo, but that's their demo. Resident Evil 4 has launched, and the Resident Evil 4 Remake has launched. The original launched a long time ago, and is the series' best launch so far on Steam, reporting very high concurrent player counts. This article is quoting 112,000. I'm pretty sure I tried it out last night, and it was around 140,000. Although I could have missed that. I was actually just playing the game. I haven't made it super far. The VRAM usage in this game, I was playing it on my 4090, completely maxed out with ray tracing at 4K, and it was running over 100 FPS much of the time. But I will say that the VRAM allocation was around like 14, 15 gigabytes to do that. So if I have time, no promises, I might look at how something like an 8 gigabyte card like a 3070 does, or a 3060 Ti, 3070 Ti, how those types of cards do, versus something like a 6700 XT or a 6800 or something like that, which has more VRAM but usually offers fairly similar performance to those Nvidia cards. It would be interesting to see how it goes in that game. The last thing I'll mention is that there's a Teenage Mutant Ninja Turtles game based on the last Ronin, I think arc that for the Teenage Mutant Ninja Turtles, which is a God of War style video game. And I've got to say, I really hope this comes out and is good. As a kid, I was really into the Teenage Mutant Ninja Turtles. I'm totally here for a super dark, gritty, last Ronin God of War style Teenage Mutant Ninja Turtle game. Anyway, I hope all of you have an excellent day.